Hello future engineers, subscribers, viewers, and students. There is another video in statics, particularly on the topic centered the moment of inertia of areas. And this is intended for slow, weak, and poor engineering students. I hope that through this video, I can transform those who are really slow learners, or everything, students who are weak in comprehension can be uh, elevated through their intellectual level. Here is the problem for the composite and for the composite areas shown, not concentric. Compute the following: Ix, Iy, Igx, Igy, moment of inertia with respect to 1, 1, and part F. I will leave this to you as your exercise. I2 to I provide the answer for you to participate in this video. So this is the guide. Remember that in the preceding slides, we have moment of inertia of a whole circle, which is pi over 4 r to the fourth. But for this semicircle here, of course, it is half of pi over 4 r to the fourth. So Ix is half of a circle, so it is pi over 4 over 8, 1 half of pi over 4 over 4, so pi r fourth over 8. Similarly, Iy is the same because we have two quarter circles. So times 2 of quarter circle, the moment of inertia with respect to the radius or diameter is for a quarter circle should be 1/4 of pi r4 over 4, so pi r4 over 16, then times 2 pi r4 over 8. Although the y-axis also passes through the centroid, Igy would still be pi over 8 r to the fourth because we have two quarter circles like that. Same is true with Ix. We have this quarter circle and this quarter circle here. But with respect to the centroidal axis parallel to x, depending on the orientation, since this is 4r over 3 pi, uh, you look at the derivation where I derive Igx by transfer formula for moment of inertia, and this is 4r over 3 pi, it is 0.1098 r to the fourth. But this is the problem. We have a composite area consisting of a right triangle, then we have to subtract the semicircle here of radius 3 as indicated in the figure. The dimensions of the triangle is 9 base, then 6 plus 6, 12 height. So for Ix, we have a ready-made formula for that, bh cubed over 4 for the triangle. Then for the semicircle, because the centroidal axis parallel to the x is this, and it is not coincident with the x-axis, so we use transfer formula for moment of inertia. And as our alternate solution, we just modify the formula for Ix of a right triangle. But in this case, I apply transfer formula for the right triangle, 9, 12 cubed over 36 plus area 1/2 of 9 times 12 is 54, and the distance of the centroid of the triangle from the x-axis is 2/3 of 12 is 8, so that's why you have 8 squared. Then we have to subtract the moment of inertia of this semicircle with respect to the centroidal x-axis transferred to the x-axis. So minus quantity with respect to the x-axis. This is the x-axis if the semicircle is rotated 90 degrees counterclockwise. So this would now be the form. So this is supposedly Iy, but in this case it is Ix. The formula is the same, pi over 8 radius to the fourth, then plus the area of the semicircle, which is half of the area of the circle, pi over 2 3 square. The distance of its centroid to the x-axis is 6 plus 3, 9. So 9 square. Calculating Ix is 2711 units to the fourth. So the alternate solution is we just modify this into 912 cube over 4 with respect to the axis parallel to the base through the vertex. Remember that from the preceding slides. So just this one, then this second term will remain the same. So 912 cube over 4 minus this value. And the answer is the same, of course, by principle. I hope that you know that already, my viewers. So 2711 units to the fourth. For IY, we also have a direct formula because this is the y-axis to the vertex. But I want you to master transferring moment of inertia from the centroid to any axis. So it is 9 cubed times 12 over 36 plus area 54. Then 2/3 of 9 is 6 square for the triangle. By the way, remember that this distance is 4r over 3 pi, which can be reduced to 4 over pi from our guide here. So that would be this distance of the centroidal y-axis of the semicircle from the y-axis would be 9 units minus 4 over pi, and that's 7.7268. I want you to calculate that. So IY is for the triangle 9 cube times 12 over 36 plus area 54, 2/3 of 9 is 6 square, minus pi over 0.1098 rather. That's our guide. IGY for the semicircle, 0.1098 reduced to the fourth, then plus area, which is 4.5 pi, this is 4.5 pi, then distance square, which is 7.7268, then quantity square. Computing, it is equal to 1334 units to the fourth. The other way is we replace this again by 9 cubed times 12 over 4 if you want, and this second term here for transferring the moment of inertia of the semicircle with respect to its centroidal y-axis to the y-axis remain the same. So this is now the centroid of the entire area. For IY, I want you to solve this into two ways in the same manner as this so that you can master calculations of moment of inertia. Do not say that you know that already. Just accept so that you can learn a lot. So I'll call that G. Then by Varignon's theorem, area barred x equals area of triangle barred x of triangle, area of minus area of semicircle barred x of semicircle. So area is area of triangle 54, area of semicircle 4.5 pi. So 54 minus 4.5 pi is 39.8628 square units. And by Varignon's theorem, 39.8628 xg equals 54 times 6 because 2/3 of 9 is 6, centroidal x coordinate of the triangle, minus 4.5 pi, area of semicircle, and its distance from the y-axis, centroidal distance is 7.7268. So that's why xg is 5.3876. Similarly, 39.8628 yg equals 54 times 8. 2/3 of 12 is 8 for the triangle. Then minus semicircle, then 3 plus 6, 9. 4.5 area, then times 9. So yg is 7.6454 units. Then for the centroidal moment of inertia, let's transfer the centroidal moment of inertia of its individual figure to this centroidal axis. So first for IGX. So IGX is IGX of triangle, which is 912 cube over 36, then plus area 54, then the distance is 8 because the distance of the centroid of the triangle from the x-axis is 8 units, and yg is 7.6454, therefore the distance is 8 minus 7.6454, then quantity square. Minus for the semicircle, pi over 8 radius to the fourth, the area 4.5 pi, and the distance between the centroidal axis and the centroidal axis of the entire area is equal to 9 minus YG quantity square. So pi over 8, 3 to the fourth plus 4.5 pi 9 minus 7.6454 quantity square. Computing that is equal to 381 units to the fourth. Then the other way is Ix equals IGX plus area barred YG square. So Ix is 2711 equals IGX plus area 39.8628 and YG is 7.6454, then quantity square. Calculating, that's 380.9. The discrepancy of zero point 0.1 is understandable because we round off values here. They are not exact values. Next, for IGY, we also transfer moment, centroidal moment inertia. So IGY of triangle is 9 cubed times 12 over 36 plus area 54, distance 6 square, uh, 2/3 of 9, 6, then minus xg, which is 5.3876. The centroid of the triangle is somewhere here, 6 units from the y-axis, and xg is 5.3876. Therefore, the distance between the centroidal y-axis of the triangle and the centroidal axis y-axis of the entire area is 6 minus xg, then quantity square. Then minus for the semicircle 0.1098 r to the fourth, 3 to the fourth, plus area 4.5 pi, and the distance between these two points is 9. This is centroidal y is 9 because that's 9 minus 5.3876. So centroidal axis of the semicircle is 7.7268. Then the distance of the centroidal y-axis of the entire area is xg. So their distance is 7.7268, then minus xg 5.3876 square. So the answer would still be around 177 units to the fourth. So another way is IGY 1334, IY 1334 equals IGY plus area, then distance square, which is xg square. So we'll get 176.9 units to the fourth. Again, the discrepancy of 0.1 is understandable. Then we proceed to part E, moment of inertia with respect to axis 1, 1, which is 3 units above the x-axis. So we transfer its figure to this axis here. IGX of the triangle, which is 9, 12 cube over 36, area 54, and the distance is quantity 8 minus 3 square, where 8 is the centroidal x-axis of the triangle from the x-axis, and 3 is this distance to axis 1, 1, so that's why we transfer. So 8 minus 3 quantity square, minus for the semicircle pi over 8 reduced to the fourth, then area 4.5 pi, distance is 9, centroid there is 9, then minus 3 quantity square. So calculating, it is 1241 units to the fourth. Similarly, we can use I11 equals IGX plus area distance square. So IGX is 1, I just use 381, then area 39.8628, since YG is 7.6454, and this is 3 units, so the distance between the centroidal x-axis of the entire area and 1, 1 is YG minus 3, so quantity square. We will get this all the same value 1241 units to the fourth. Then for your part, I want you to compute I22 in two ways also. It's up to you. Then you will have this value. I will not suggest so that you will think for your solution. Remember two ways, 697.2 units to the fourth. So that's it for this video.